Okay, I've started the recording of the session for later review. You guys that show up in person, if anybody else that wants to see how it works with real equipment when they're off campus. Today on the schedule, we're going to cover these two labs, 2125 and 3224, and we're going to do them on actual real equipment. When you're doing them remotely, you can do it just as we do it in here, because the packet tracer equipment is exactly equivalent to what we use here in the real lab. Okay, so these two labs are located in the student lab printout section, 2125 and 3224. In the first lab, they tell you to connect two PCs, our virtual VMware PCs, to a home router. In the second lab, they don't say, but you can just, when we do the second lab, just choose one of your PC or PCBs and use it, because he's going to have you determine what the MAC address is of that particular device. Okay, so here is a home router. It's a real home router. It's a Linksys home router. Linksys was bought by Cisco. It says Cisco Systems on it. So you guys are all plugged in. Your virtual machine, VMware, PC or PCB are both plugged into. I strung them up on the top of the lab there in the back of the room. It's all plugged together that way. I would have rather have it at your workstations, but my key broke to unlock the thing and plug in the power cable, so I can't do that. We'll go back there. So I'm going to step through this first lab, 2125, which is determining the IP address of a computer. And they don't have a logical diagram on here. But what it is, it's two PCs plugged together. Let me see if I can pop up the old version of Packet Tracer. You guys looked at the thing I did the other day. I showed you the new Packet Tracer and the really cool physical stuff it has. So, oh yes, I've got to log in. Oh yes, okay. Can I log in? Can I check this thing that says? Okay. I was looking for the little button that says click here, and you won't have to do this each and every time you do this. The new version of Packet Tracer has got a more improved physical view, but even the existing old version 7.3 has got this, so we can click in physical, open up the city, open up the office, open up the wiring closet, and add a table. And I'll shrink this down so we can see the table. And then I'm going to put a couple of PCs on there. PC A and PC B in this case. We don't need to renumber them he doesn't do that in this lab. Most of them, they call it PC A and PC B. So I'll click on End Devices, and I'll just drag a PC there and a PC here. And let me see if it allows me to do like what I did in the tape presentation the other day. I'm going to see if I can add that wireless router. Where's the wireless router? Go back here to the network devices, Wi-Fi's, home router. Can I put it on top? He forces it to be on another table. Okay, the new version, you can put it right on top of the other one here. So I'm going to make this a little bigger so we can see them a little more. To make it a little smaller so we can see the wireless router. Come on, where'd you go? Here we go. Now we can see it. Okay, so in the existing version of Packet Tracer, the new version that I showed had this really nifty feature that I could click on the Ethernet plug and then click on the Ethernet plug on the router, and it would show the cable drooping between the two of them. And then you could click a button and said, dress up the cables. In the existing older version of Packet Tracer, it's the old standard way of doing it, so I can click. Oh, I got to click on the connection. So I'm click on the lightning bolt connection, click on the Ethernet cable, and this is the way you guys are actually wired up in the grid today. I'm going to click on here and choose the Ethernet cable, and then click on the router and choose one of the plugs. And it sort of shows a wire. It's kind of hard to see. It shows a wire, and it's already dressed back somewhere where you can't see it drooping. I like the new version because you can see the existing wiring much more easily. Then I'll click on the Ethernet connection, choose fast Ethernet, and plug it into one of the other ports on the router. And then you would go into the PC and go to the desktop and click IP configuration and click the button that says Dhcp. And do that on the second one as well. Desktop IP configuration, which is fairly close to what Windows looks like. And eventually, then we get an address. But I'm going to do this with real devices. So let me minimize this. Let me minimize this. I'm going to start my VMware workstation. Now, a couple of you guys sitting at a workstation, you've never sat up before, you won't be able to start your VMs. I'm going to go through the walkthrough, stop the recording, and now help anybody that's got any problems that can't start their VMware workstation. Okay, so I'm going to click on PCA, and I'm going to, oh, well, can I take ownership? Well, sure, I'll take ownership. Oh, I can't take, oh, come on now. Oh, I already have it running, that's why. I already have it running. Trying to start it when it's already running. So let's see now, where is it already running? Here it is, it's already running. Okay, PCA, PCB, they're already running. Okay, so I'm going to go to PCA, and in the lab instructions, they say, connect PCA, PCB to a small home business wireless router, and all you guys are plugged into, you can see them sort of laying on the top of the racks up there. I disconnected you from your normal industrial quality managed Cisco switch that we normally use for all our labs, $500 Cisco switch, and I plugged you into a $50 home router. So that's all plugged together, and because of the uncertainties of the virus before all this started, you would plug in and you could create your own stuff and get physical experience plugging wires together and understanding the consequences of what happens when you don't plug the cables in properly. Things don't work properly. That's one thing I love about this new version of Packet Tracer version 8 is that you can click and plug in cables just like you would in a real physical lab, and you can see how the wires lay down. The logical view kind of sort of hides that stuff from you. Okay, so we're all plugged together on those, and Ethernet cables are plugged up. So step one at the beginning of the first page, it's connected. You're connected to 2 ports. You've seen these home routers. They all have the exact same topology. They all have a blue plug that connects to your cable modem or your DSL modem or whatever your broadband connection that you get your internet service provider from. And they have 4 plugs that are typically yellow that you can plug your wired home devices into, like a desktop PC. And then they have Wi-Fi circuits, so you can connect all your wireless devices, like laptop PCs and all the other things that can send those type of connections. So that's all plugged together. Okay, so we're supposed to log into both computers. I have both computers running here in my VMware. It's tabs, PCA, PCB. I can look at either one. So we need to make sure they're set in the bottom of page 2, step 2, set to auto configure. Now in the previous labs that were already, this room is in dual use by 2 different Cisco classes. Okay, this class and a more advanced class, and they probably have previous settings on there that you would need to change. So there's 6 ways in Windows to get to any control panel. He tells you to click start, settings, stuff like that. I put a shortcut. Cisco Lab shortcut. That's a shortcut to get straight to the network control panel for that network adapter. I'll click on that. Then click the word properties. And this is equivalent to, he says click network control panel, change adapter options, properties, and at the bottom of page 3, there's that screen right there. Okay. So he says select Internet Protocol version 4 and either double click it, or you can single click it, select it and click properties, or you can just double click on it. Now yours probably is not going to say obtain the IP address automatically. We talked about something called DHCP, Dynamic Host Configuration Protocol, which is universally used by all home networks and business and commercial networks, because it's such a drag to have to be the guy to statically configure all of these addresses over and over again when everybody moves from one office to another every 6 months in industry. Before 1995, that's what we guys had to do. Yeah, 250 people moving around all the time. They're Macintosh users. Oh, they already know everything there is to know about computers. So when they move to another office, they simply make up an IP address and put it in there, and it messes up everybody else on the network. So about 1995, they came up with this dynamic host configuration protocol thing, and everybody adopted it right away. So now the 99% of all the devices that plug into the network, student PCs, employee PCs, laptops, phones, anything like that that needs a network address is going to get it automatically. You won't have to go into some screen and figure out what network you're on and figure out what your default gateway router address is and all that other stuff. It'll automatically get that address assigned to it. So in this lab, all home routers do this. So I'm going to click the button that says obtain the IP address automatically and click OK. And you got to click the second OK and click close. And then I'll go do that for the second PC. Go into properties, go to IP version 4, and it's already checked. I was checking it earlier just to make sure my router was working properly. Click OK, click OK, click close. So on page 4 of the lab, he tells you to click the button that says obtain the IP address automatically. Click the other button that says obtain the DNS. Oh, we haven't talked about DNS yet. That's the thing that you don't have to type in binary numbers when you go to a website. You type in Cisco.com. You type in Microsoft.com. You type in Facebook.com, whatever you want, and it translates that into the 32-bit address for you. I call it the directory information operator of the internet. Now let's document our address settings. Now the weird thing about DHCP is the address that you were granted by the address server, the DHCP server, does not show up in the network control panel. You got to type a command from the command prompt, what we old timers call the DOS prompt. So I'm sorry, the electricians are here working today. They're going to be here all month. They're changing the lights out. We have the old lights. They were in here this morning getting ready to cover my lab with plastic, and I had to chase them out and said, go to that room instead. There's nobody in that room. Please, I have a lab today, I have a lab tomorrow. Please do some other room. They're going to be here for a month. It's okay. They have plenty of other work to do. So they put in these new LED lights. This is part of the $800 million that you taxpayers approved for our junior college district last November, before all the chaos started. And so they're spending money like crazy. You know, it's going to save the taxpayers money. LED lights use less power. So we're going to cut our light bill down. So I want to go to the command prompt, and he tells you how to get to the command prompt. From PCA, right-click Start and choose Command Prompt. But I think in the current version of Windows, when you right-click on it, there is no command prompt in there anymore. But you can click this black screen I have at the bottom here. This is the command prompt. Like if you type dir, you get the list of files. This is what we old-timers worked with before we had GUIs, graphical user interface stuff like the Windows system. We didn't have no stinking GUI. We didn't need no mice. We typed at the command line. We did everything at the command line. Okay, and so he tells you that you're going to type a certain command at the top of page 5. We're going to type a command called ipconfig. There's no space, not like that, no. ipconfig. If you type ipconfig just by itself, it just tells you, oh, that's what I needed to know from my network control panel. My IP address is 192.168.1.100. The other one's probably going to be 101. Let me check it. The subnet mask, I don't like the word mask. It sounds like it's the Phantom of the Opera trying to hide something from you. I would rather be called the network yardstick or the network ruler. It tells you how big your network is. So in this case, the 0 tells us, that last 0 tells us that it's like an area code and the telephone number. The area code tells you which telephone network you're on, and then the last 7 digits tells you what's your individual unique number on that. In the 817 area, Fort Worth, you can have a 7-digit number. So this tells us that this network has about 250 available addresses. And then the default gateway, that's my friendly neighborhood router. At home, that would be your home router, which would be connected to cable or telephone. It's time for the poll. If you are on the telephone company, raise your hand. No one's ever on the phone company. I'm the only one that's on the phone. Why? Because the cable company is like five times faster for the same price, right? So I take it by your silence that you are on the cable company. So it's usually 95% of the people that take the classes take the cable stuff, because my phone company system on is $50 a month, something like that, and I get 75 megabit. I think you can pay the cable company the same $50 a month, and you get, what do you get, 300, 400 megabit? And there's some deal now, you might even get fiber and get a gigabit. about that price. So in my neighborhood, they're pushing pipe. They're running fiber. I don't know if it's a phone company or the cable company. So I'm going to type the command that he said, ipconfig space /all, and it gives you more information. So in the lab, he says, what is the IP address of the computer? And there's the IP address of the computer. Here's the IP address, right here. What's the subnet mask? 255.255.255. What's the default gateway? The 192.168.1.1. That's probably the same value as the default gateway of your home router. Almost all of them are. Who are the DNS servers? Your cable company will have a DNS server. So in this case, they have the DNS server, and it maps it to your home router, and your home router automatically talks to the DNS server that's just your internet service provider. Is DHCP enabled? Yes, it is. The DHCP server in your router gave you that 192.168 number. What is the IP address of the DHCP server? It's going to be 192.168.1.1. On what date was the lease obtained? Is this calendar correct? Is this clock correct? 9:21. Yeah, 4 minutes ago. When does the lease expire? It expires, looks like he's using like a 48-hour lease. Now, we're going to test using our ping command. Ping is a very useful command for people that build and troubleshoot networks to test if there's network layer connectivity between different network devices. So we know that what the IP address of this, let me go to PCA. I should have been on PCA. Let me go to PCA. And I'll type ipconfig by itself. So I can see my IP address is 192.168.1.101. And we did the ping in an earlier lab. There's usually a normal series of steps we go through when we do the ping. Just a step-by-step thing to make sure everything's cool. So the first thing I'm going to ping is that 127.0.0.1 address. That just tells me that I clicked the check mark box in the network control panel and I turned on that networking. That's okay. Now the next thing I'm going to ping is my very own IP address. What's my very own IP address here? Ping 192.168.1.101. And that should work because it's your own network adapter that's present in your own computer. It should work just fine. Now, occasionally we're using VMware virtual machines. VMware is the market leader in this. Microsoft also has a thing called Hyper-V that's the same sort of a thing in the sense that Spanish is similar to Portuguese. They both impart information. They just do it with different kind of code. Okay, occasionally these VMs go crazy and they won't communicate. So if that happens with you, the machine may have become misconfigured, and I can usually fix that pretty quick. Okay, now I'm going to ping on PCA. My address is 192.168.1.101. I'm not going to try to ping my neighbor, where it actually goes out through the yellow wire connected to the first VM, goes to the router finds the best path and goes back to the second yellow wire to my second VM, and I should be able to get that connection. I should get a reply from that. So I'm going to do ping 192.168.1.100, and it works. Occasionally, the very first ping will fail because of this address resolution protocol thing we talked about, which lines up your layer 2 MAC address with your layer 3 IP address. Has to do that every few minutes, once in a while. So the ping should be successful. If it's not, when you do this yourself, I'll help you try to figure out what's going on with it. Okay, now in step 5, they ask you some similar questions about what they asked you for PCA. What's the IP address of the computer? Now your A and B might not be the exact same numbers that mine are. Okay, you may be 100, you may be 101, you may be 102, you may be 103, something like that. It'll depend on because you guys are sharing those things back there. Now here's the tricky step. We're going to go to PCB. I'm on the last page of lab, page 7. I'm going to go to PCB and change it from that automatically configured address that he got. I'm going to change it to that address manually and see if it still works. It should work just fine. So I'm going to go to PCB, and PCB's address is 192.168.1.100. Okay. So I'm going to go back to my network control panel. and change it from obtain the address automatically to I get the typing address, 192.168.1.100. What was my default gateway? Oh, 192.168.1.1. That should work. Let's see what happens here. So like Reagan said, trust but verify. I'm going to type ipconfig. Looks like I'm still the same address. Should I still be able to ping 192.168.1.101? I can. So it doesn't matter to the workstation, to the host machine that's connected to the internet, how he got that IP address. Magic Keebler Elves gave it to him, or I typed it in manually. So long as it's a proper address, not a duplicate address, not a bad address, it's, you know, off some other network, it should work just the same. Now it tells me to go back and return it to automatically configured. So I'm going to do that. So I'll go Cisco Lab, properties for obtain the IP address automatically. And it should still work. It may take a second. Okay, it's working just fine. Okay, now, once you finish that lab, you don't have to disconnect, do anything like that. Just choose one of your VMs, PCA, PCB, doesn't matter. Just choose one. I'll use PCA. So this is lab 3.2.2.4, and we're just going to determine what's the MAC address of this PC. So he says on page 2, open the command prompt. So I'm going to click on the command prompt's already open. If it wasn't there, I could click on the little command prompt shortcut I placed on the screen. Or you can do run cmd, and that'll do it too. 7 ways, everything you do in Windows. And we're supposed to type the command. I'm going to make this screen a little bit bigger because when I type ipconfig/all, it's bigger than this little screen, this default screen. So ipconfig space /all. That gives me the IP address and all the other stuff as well. Now, it's going to look slightly different from the one you see printed in your lab report. So on page 3, it says, what is the description? Now, they have several lines here, but you only have one. The description, Intel network connection, is the description. Then it says, what's the physical address? That's the line below it. 000C2980. Your number would be different. All MAC addresses are required to be unique in the universe. Because if 2 devices end up in the same network and have the same MAC address, it would break the entire network. So we have to keep the riffraff out. To get a MAC address, bank of addresses for you to manufacture, if you're a company that makes devices that have Ethernet plugs on them, you have to pay the IEEE $1,500, and they'll give you a bank of a couple million addresses. So it's only a few cents per device. Okay, so in the next part, we're going to analyze this MAC address. Now, in this hybrid, in this virtual VMware machine, you should only see the one network adapter. If you did the same command on the Windows 10 host operating system, not these guest operating systems, each of these PCs actually has 3 network adapters in them. There's one that goes off to the internet, which we don't use in the labs. This is really dangerous. It's a big problem teaching networking and security because we might do bad things to the real production network for that company. Okay, so the administrators are looking at, remember, the administrators are not technicians, they don't understand what's going on here. But they're thinking, wait a minute, you're teaching these guys how to reset passwords? Oh, what if they reset the password on the Web Advisor server and change their grades to all A's and issue themselves $1,000 tuition refund checks? That could be a problem for the administration. Yeah, that's a business problem. Okay, and so we're using all these weird protocols, you know, Dhcp and all these broadcasts, and we're going to mess up the people in the librarian. Now the librarian, head librarian is going to be mad at me because I'm giving him bad IP addresses. So to solve that problem in teaching networking, we do a couple of things. We air gap isolate all our stuff. So what we do on these VMwares doesn't touch the real Tarrant County production network. We'll use another technique. There's something called VLANs, which is we use in another later course. VLAN is a method of isolating one department from another department. They're plugged into the same Ethernet switch. and maybe the marketing department doesn't want anybody else to see the secret marketing plan for next year, so we isolate them behind their own VLANs. So generally speaking, we use a combination of these techniques. I have an air gap rack mount here that doesn't touch the real network, and we're behind the VLAN, which we normally do in the real world anyway, because you don't want more than a couple 100, 200 people in one particular broadcast network. So part 2, analyzing the parts of the MAC address. The MAC address is in 2 pieces. The first half of it is assigned to the vendor, the manufacturer, who makes those devices that Ethernet plugs on them. They went to the IEEE, they paid the $1,500, and they get the ability to use their unique 6-bit, it's called Organizational Unique Identifier, OUI, and they get 1 or 2 million addresses they can use. And then when they run out, people like Cisco and Dell have run out, and they have to go out and get another one. They've got through several of them. The last part is like a serial number. And each manufacturer agrees that he will only use the first half that was assigned to him that he paid for. And the last half, he can start with 0, 1, 2, 3, 4, 5, and go through all the possible values of those 6 digits, which is in hexadecimal, not decimal, and get all these unique different values. So you can always determine by looking at that first 6 digits, who was it assigned to. So on the next page, we're going to go to the Wireshark Web Page. Okay, let me see now. I'm going to bring up my browser, and we're supposed to go to Wireshark. I think it's easy standing up here, typing with a bunch of people looking at you, get your own class and see what it's like. So wireshark.org. /tools /OUI lookup .html. You guys know about, did you take Computers for Terrified Adults? That's what I call our fundamentals, our computer fundamentals class. What's HTML? That's a web hypertext markup language. It's like a macro language that how you format the page. I call it has too many links. Okay, now we're going to look up what was our prefix? Oh, I have to flip back and see what our prefix was. I should have wrote it down. Let's see. Go back to the PC, and it looks like we're 000C29. Oh. 000C29. Let's look that up and see what it finds. And that belongs to VMware. You're running the VMware workstation. So that's consistent. Now, if you did it on a real computer, it might say Dell. We all buy Dell computers here. Okay. Reflection question. I do not require the reflection questions in my classes, but the question says, why might a computer have more than one MAC address? So I'm going to go to my real computers prompt. This is my real computers prompt here. And I've got, let me do it this way. I'll go to the network control panel. There we go. So TCC production. That's that blue colored wire that comes out of the back of your PC. It goes to our real network. Internet. Okay. So when you logged into the computer with your name and the password, it went through that blue wire. It plugged into a Microsoft domain controller somewhere at our data center downtown. He checked your password. He says, looks like a good password. Give him access to that computer, unlock that computer so he can do stuff. Cisco 1 and Cisco 2. Those are, you can see the yellow wire that comes out of the back of your PC. I've got plugged a second network adapter into all these PCs. The third one is a USB attached Ethernet adapter. That's useful if you got a laptop or something that's hard to open up. So that's your PC 1. Cisco 1 is your PC 1. Cisco 2 is your PC 2, PCB. Goes back to the rack connection. Anytime you install VMware on a computer, he installs a ghost adapter. It's that VMware VMware virtual Ethernet adapter. So you can, if you install Hyper-V, you're going to get a Ghost Hyper-V connector as well. So why do these computers have more than one IP address or more than one MAC address? It's because teaching networking is looked at by the upper administration as a danger and a hazard. The hackers are going to break into the system, so we have to do everything we can to isolate them. So your PCA and PCB are connected to two separate NIC cards that never plug into our network, never plug into the company network. They only get back to the back. So you can make all the mistakes you want to, or do anything that would mess up. If it was plugged to the real physical network, it could mess up the people in the library or whatever they get mad. So we do that. So most computers only have one MAC address because most computers only have one Ethernet adapter. You plug it into your home router, or well, your laptop computer. How about you? Joseph? Your laptop computer.
Yes, sir.
It has a Wi-Fi connection. Does it also have an RJ45 that's going to be plugged into the real network? The newer ones don't have them. They're too thin.
Yes.
Yeah. Okay. So the newer computers are so skinny that the RJ45 won't fit in there. You have to plug a little jumper into them. That jumper thing is like what I have on back of my for PCB. So if you have a laptop computer and you look at it, you might see two MAC addresses. You might see two IP addresses. Yeah. Okay. All right. Hang loose. I'm going to stop the recording.